So welcome to another episode of the Business of AI podcast. And today I'm delighted to be joined by Nikolay Gurianov, the founder of Braintree. So Nikolay, it's great to have you here today.
Oh, thank you very much. Very interesting to speak to you.
And I'm really looking forward to finding out more around Braintree because, I'd love to find out exactly how you got into doing what you're doing today. So a bit about your story, but then also what Braintree does, because I think you're doing some pretty interesting and exciting things with AI. And I'd love to find out more and then delve into that. So could you start off by telling us your background and how you started Braintree?
Okay, my background, I'm an expert in complex software and symbolic systems. And we started Braintree before AI became to be so fashionable. And we are based on early technologies, which was called old-fashioned artificial intelligence. And this technology, it was a view how to make machine thinking. And this view was that the machine should be just an interface between humans and data. And as soon as it is an interface, and because we humans are symbolic systems, we are biological symbolic intelligence. And that's why in 70s and beginning of 80s, thinkers, they said that it should be symbolic. And we took this idea and we just recognized that possibly it was right time because it wasn't really possible to do it earlier to make it happen just because of technical restrictions. But now, having all achievements with hardware and data exchange and everything else, it is possible to start working with symbolic systems.
So could you help us understand how that symbolic system might work? And I'm sort of trying to remember back because many years ago, I studied experimental psychology and philosophy. And part of what we were doing then, this is back in the 90s, we were building some, or the PhDs were building the neural networks. And I remember there was some thinking there about how we would try and replicate the way in which the brain actually processes information and then captures that into the neural networks that would allow it to sort of mimic the way that human thinking works. But I'm not sure whether it's that which you're doing or something else. I'd love to understand it in a sort of more concrete level. What do you mean by symbolic?
Symbolic, it's very simple from one hand. From the other hand, it's very complex. We have two kinds of intelligences in our, let's say, consciousness. And the first one is recognition. And if we cannot recognize information, if we cannot recognize data, there is nothing to operate with. And that's why this type of intelligence is called sub-symbolic. And this is what 99.9% is other companies are doing now. Because if we'll try to generalize it, all, let's say, modern algorithms, they are mostly just to recognize it, to recognize a pattern, and to bring this pattern with the highest possible level of probability. But when it comes to second kind of intelligence, which is symbolic intelligence, it is not about probability. It is about generalizations and abstractions. And this is where we are operating with symbols. We are not just recognizing, oh, it is a human, or it is a dog. We understand that it is a dog. We are making just conceptions, and we are using these conceptions as a symbol, and having this, let's say, some kind of symbolic library of symbols, we can interact with each other. And I can say, oh, it is a dog. And because you have a symbol of a dog, you understand what I said. It doesn't mean that we both can see the dog. Or, for example, let's imagine you have a dog and you're saying, oh, my dog is so cheerful today. And my brain is building, using my symbols, is building an absolutely exact picture of your dog being cheerful.
Mm.
And this is how it operates. And this is what, unfortunately, there's nothing wrong with sub-symbolic systems because it's just vision, hearing, and everything. But these systems, they have limits. And this is where expectations are far away from possible results when now AI company are claiming that, oh, we'll do this, we'll do this. Unfortunately, sub-symbolic technology or sub-symbolic view or sub-symbolic models, they have limits, and we've already hit the ceiling.
Interesting. So I love that example you gave there of the cheerful dog. And it sounds like there's a concept in your head of dog and the concept in my head of dog, a symbol. How much is this based upon sort of understanding of human consciousness and human brains? First of all, is that still a part of this, or is this now so abstracted that it's almost just happening in computers?
First of all, computers, they don't have consciousness, but we do have. And that's why if we want to use world of data, I mean digital data or digital universe, we need to build an interface which has some kind of consciousness, and it is digital because we are using digital information, but it is symbolic because we are interacting with humans. And that's why it's a very simple model: human, digital universe, and interface between humans and this digital world of data, which has to be, I'm afraid, symbolic system, digital symbolic consciousness. And it doesn't mean that it should be more complex than human consciousness is, because brain is a very, very, let's say, complex and very complicated hardware, and the computers are far away from complexity of the human brain. But we can start building now some autonomous systems which can interact with humans, which can be useful and absolutely positive about it.
Okay, interesting. So it's we're starting to see how that sort of symbolic concept then is useful in the interface, not just between human to human, but also between human and machine. I think we'll probably come back to world models and how those fit together as well. But I wanted to ask you, kind of what you think is broken and why you think we have to come up with this method. Because at the moment, when we're looking at the companies who are building out a lot of the current foundation models, they're very successful. Some would say that they're almost being too successful at the moment in terms of they're getting adoption. So what caused you to want to create and explore this alternative model?
There's nothing wrong with what we've already achieved, but it's like a proper discovery. You've achieved the peak, but being on the peak, you recognize that there is another peak behind it, and this is what's happening now. And again, we are not arguing, we are not blaming modern models, we are not blaming what people are doing now, but it is not what we aimed to do, because we humans, when we are interacting with each other, we are not interacting on a probability. Can you imagine if we are speaking to each other, and instead of using exact words and instead of shaping our conversation to exact meanings, we would start using probably correct words. And very, very soon we'll be saying just a, and that's it. Because or for example, the most common words or the mostly used words, just that's why it has to be different. And there are restrictions in current, let's say, views and models. And what we are trying to explain, what we are trying to bring to the market is how to avoid these restrictions, how to avoid these limits, how to come further to get into a new peak. which is not end of the story. It's just an evolution of technologies, and it is an evolution of human consciousness, and it is an evolution of our civilization. It's quite normal. There's nothing wrong with it.
Yeah, I think what's fascinating here is in the context of talking around things like AGI, artificial general intelligence, or ASI superintelligence. The debate now has moved from scaling up the existing models, and it's moved to talking around the sort of advanced world models. And someone like Jan LeCun has just created his new startup. I think he got over $1 billion funding to go and set that up. He's famously been a real advocate of these world models in order to achieve AGI. Is that the sort of direction which you think that the sort of industry and research academia are going to be looking at? Is that the next paradigm shift forward?
Again, in my view, it's when you are hitting a barrier, and because we are curious, we always want to come over, and we always want to be behind this barrier. And what Jan LeCun or what other, let's say, big names recognize now, that yes, we are in a dead end, and there is no way to achieve more just increasing power, increasing computing power, increasing electricity and whatever, because we cannot bring everything just to make one step up. And there is let's say, very, very understandable academical restriction, which is just it won't happen, and that's why Jan just decided we need to change the model, and he said we will make a world model. But it is an answer for a question: what's next? The next is, yes, world model, or whatever you call it, AGI. But the real meaning behind it, how, and how you are planning to make this model. What are you really doing? What is just behind these words? And again, I don't want to sound too much ambitious, but I'm not judging others, but we are definitely a company which has some answers, if not all, but minimum few answers, how and what we are really doing.
Amazing. So Braintree and the symbolic AI that you're creating is a part of the solution that would fit into these new paradigms. So what's changed? What's enabled you to be able to sort of build symbolic AI now? Is it that the level of compute is there? Is it that the research has got there? What have been the drivers of that change?
The driver is an evolution of biological intelligence. And the evolution gives few rules. One is that it never stops, and secondly, it is always dynamic. And in our model, what we are doing, we don't have anything fixed. And we looked at the evolution, and we could see that the real intelligence came when the nature designed completely autonomous intelligence based in one species, and they can exchange information. And secondly, that it is constantly dynamically rewriting itself, if you understand what I mean. And our memory is constantly rewriting itself. And we don't have a fixed memory. You before our conversation and you after our conversation will be, your memory will be different. And you have to rewrite your model completely, or sometimes not completely, but sometimes you have to rewrite it completely, saying, oh, I was wrong with this, but now I'm right. You're still possibly wrong, but your memory has changed. And that's why the difference between what is done on the market and what we are doing, first of all, we decided and we started working from the very, very low level. We started with databases, and we designed designed a dynamic database, a dynamic hypergraph, which works completely different from any other solution on the market, any well-known or unknown, what we know from the market. And it works like human memory, and it constantly rewrites itself and constantly remodel the structure of data. And this is where we can see a big step, if you like, or if I can say it. Yeah.
Okay, great. Well, I mean, it sounds sort of fascinating in terms of where you're getting to now. What are the implications for the need for compute and therefore the need for energy? Because that's been one of the main restrictions which we found as an industry, is that a lot of the models and therefore the services, the companies that rely upon those models, they need a lot of compute and they need a lot of energy. How is your symbolic AI going to change that?
Again, as soon I mentioned that we are following the nature, and our slogan is nature of intelligence. And this is where we can be very modest, that we're not doing anything. We are just trying to see what nature has already done. And as soon I mentioned the human memory and human brain, and it is very efficient. It is very energy efficient, and it is very efficient with computing power, because each neuron is not a supercomputer. Each neuron is some kind of, let's say, very slow processor. And we took this model, and we recognized that if the model is right, instead of increasing power, it is decreasing power. And making our database, making our dynamic hypergraph, we recognize that, first of all, the size of the data is constantly shrinking, because our memory is always constantly optimizing data. And secondly, it requires less energy. And this is where, comparing with, let's say, common technologies on the market, which are excessive, and we could make tests with it, let's say, for the same result, we're using hundreds, sometimes thousands, sometimes tens of thousands less electricity, which is a good sign. And secondly, the size of the data is shrinking, like in 100 times. Again, please don't judge me too much, but sometimes in 1,000 times. And this is where, following my sorry, difficult, I lost the word in English. My analogy about human memory. Human memory is not expanding. Yes, it is. We are getting more and more clever, but it does exist in a very optimal way. And this is how our technology works.
Yeah, it's fascinating. It goes back to that conversation we had at the beginning around modeling the human brain was how a lot of the computer science sort of started. But back in the 70s and the 80s, that sort of early research, they didn't have the compute to be able to start to model the brain or the neurons, and it really only kind of kicked off as the compute started to build in the late 80s, 90s. Now fast forward to today, and actually what you're describing is the ability to really model the system-wide way in which the brain is processing and storing information, and in doing so, not only are you replicating the ability to do the compute of the brain's compute, but you're also replicating the huge efficiency which the human brain has to be able to not have to have the whole brain on using energy all the time, but just having very small kind of loci where there's specific bits of processing happening or distributed across neurons. And I can see why that model is now much more energy efficient than having to have a huge language model on a large data center running all the time. So that's a much more energy efficient solution.
Yeah, absolutely. And we are on a process of testing it to having official tests. And all these tests, it shows that we are following the let's say way of nature. We are getting more and more energy efficient. We are taking less and less computing power, and we managed to bring nearly everything into real time. And this is where having delays and or using too much computing power is not how we are operating. And can you imagine again if we are speaking to each other and to make a right choice or to choose the right word, it would take time. It would be a nightmare to speak to each other. And this is where again, it's very subjective in my view, but if you have results similar what nature did before, it means that you are in the right path.
Yeah. And does that mean then that you're working with so neurophysiologists to understand the latest science and research to understand how the brain works? Because I'm conscious that that field is constantly evolving. They're using other techniques to be able to understand how things operate, not just at the neuron, but almost like at a cellular or even a subcellular level to understand how everything operates. Is that science feeding into the symbolic models that you're creating as well?
Yes, and it's very interesting because you're the first person who asks such a question. And yes, when we started our researches, the first year or two, we've been studying how human brain operates. We've been studying different algorithms, and it doesn't mean that we implemented these algorithms, but we tried to understand what would be a right model. And as soon because from the very beginning we decided to build an interface between human and the digital world, and it means that it should be a suitable bridge, a suitable, let's say, connection between computers and humans. And that's why we had a huge study, hundreds of pages and really huge files to read and to understand about human brain. And from the very beginning, we started building a concept of digital consciousness. And we even gave him a name, Sunny, from the very beginning. And not Sunny, Sunny.
Sunny. Okay.
Yeah. But we humans, we are always trying to bring, let's say, some kind of anthropological view on everything. And it's quite normal.
Absolutely. I think it is hardwired into us, isn't it, to see there's a word for it, and I can't remember what it is now, but it's that sort of drive that we look for faces and humanity, and we anthropomorphize objects around us. Yeah, fascinating stuff. So as we're just sort of thinking then around how this can be used from a sovereign AI perspective, I'm sort of thinking around part of the work which we're looking at the moment, which is around where this technology is going to be developed. And you've talked a bit around the infrastructure. And I wanted to sort of understand, is your vision that this could be part of a tech stack that would enable sovereign AI capability, maybe here in the UK or across Europe? I mean, is that part of the plan here, that we're sort of building a tech stack, a sovereign tech stack?
Yes, and the key concept for this conversation is efficiency. And it comes into, if you have such sizes of electricity, if you have some sizes of data centers, if you need to transmit information, where these data centers are, and following what we are trying to bring to the market, it allows to enable a concept of sovereign AI. Because let's imagine, let's be modest, and we can prove that the same data you have, we can keep it 100 times less size. And if you need 100 data centers, I need just one data center. And it's very simple. And if you need to feed your data centers 100 times more electricity, I just need one item, and that's it. But we are speaking about 1,000 times less. And it means that it is a completely different infrastructure. There is no need to have cables through the ocean, and we can localize everything. And this is where coming into concept of sovereign AI, the other keyword would be localization. You need to localize everything. You need to localize your data. You need to localize data exchange. You need to decrease data exchange, and you need to control it, because just a matter how sovereign you are, you might have a huge treasure, but if you don't control it, it means that you're not as sovereign as you would prefer. But if you have the same size, the same treasure, but the size of it 1,000 times less, you can control it. You can keep it just in your hands, and this is where your control will be real, and you can build something about it.
Yeah, yeah, it's really interesting. And
there is no, sorry for interrupting, but there is no need to overcomplicate things. We need to start with something which is very basic and simple. For example, there was one interview where I really liked Elon said that it is necessary to have clean information and homogenized. And this is what is happening in our brain. Can you imagine if you are getting information which is just full of noises and everything, you can't make a decision, you can't be clever. And if you are not homogenizing information, what our brain does, because vision is one channel for input, hearing is different one, and all the senses, they're different. But inside our brain, we can switch these channels, and what you could see, you can tell it. Or what you could hear, you can express it, you can make it an audio file. And this is where we need to operate with it. We need to make it like, again, like human brain. And this is what we, I'm afraid, did. We managed to homogenize data from different formats, and it works like one environment.
Yeah, no, it's absolutely fascinating what you're doing there. And we're talking around human consciousness and how do we actually try and understand how that works in the brain in order to then replicate that. And you've gone down this sort of symbolic route of trying to represent it. I mean, I'd love to have perhaps you can on another episode of the podcast, kind of a deep dive into some of the work you're doing to really understand human consciousness. And it starts to become a very philosophical question, then also a neurophysiological question as well, to understand all of those. I think these areas are often very overlooked, but they'll be increasingly more important as we start to kind of build these more powerful machines. As we start to wrap things up, though, I wanted to kind of come back to that concept you talked about before of digital consciousness, symbolic digital consciousness, because that, for me, is really fascinating. And I want to sort of to understand what you see as being the next steps, because it feels like what we've been talking around is very much cutting edge, a new paradigm. It could be the future. It should be the future. It has many benefits. But how do you see that sort of future emerging? Is it something, well, and also how can it coexist alongside humans?
If we are following our model, first of all, it is absolutely positive. And it is a part of human evolution. And regarding to the future, first of all, if we'll start using technology like ours, the digital infrastructure will become to be very efficient. We saw it in nature, and nature is constantly trying to make everything efficient. And we are part of this nature, and that's why we're not following this rule. Secondly, we humans, we have intelligence, and our intelligence is operating now on our own limits, which are called anthropic limits. And we have these restrictions to understand big data. I mean, when we can understand information, but it's too big. Secondly, complex data. When we have many small pieces, we can understand each piece of information, but we cannot put it together. New data, which is, for example, you have some knowledge spread everywhere, but you cannot, because it is, you don't have access to it, you cannot build a new knowledge. And something which is unknown, like, I don't know, black holes, or where universe finishes and where the bodies of universe. And symbolic systems, symbolic digital consciousness will help us. It will be like an extension for human intelligence, and it will help us to overcome these 4 anthropic limits. And this is where we humans will evolve, and it's absolutely normal. We will evolve with nature, will be implemented on our planet better. And it will be just different civilization, and we need just to be positive. And what we are doing is absolutely fitting this model, and this is what I personally and our team believes in, and what we are trying to bring.
Wow, well, incredible to have that view of the future there, Nikolay. Thank you for sharing that with us. As we sort of wrap things up now, I wanted to just ask you, how can we find out more about your work at Braintree? And if there are some of our members out there who want to work with you and partner with you, what's the best way for them to actually sort of leverage what you're building in maybe some of the businesses and the solutions that they're creating?
Yeah, we are absolutely open, and we are a British-based company. I'm a British businessman and British researcher, and if there is any, let's say, need or request to understand more, just let us know. And we are ready to show, not just to say it in words, but to show it on the screen. We're ready to show tests. We're ready to explain models. And it's not just an idea. It is not even a proof of concept. Let's say it is a working prototype. It's rather a developed stage of the technology.
Fantastic. Thank you. And yeah, your website, braintree.com, has more information there. Is that a good way of being able to kind of get in contact?
Yeah, we are planning to rebuild it in a month time, because we were advised that we need to simplify it a little bit. It is interesting for people who are in researchers, but not too interesting for people who are trying to get just first feeling and first impression of the technology. But there are some enough interesting information there.
Yeah, great. Well, Nikolay, we're going to have to wrap things up there, but I'd love to get you back on the podcast or maybe do a further webinar with your team to really understand how all this is developing, because it is absolutely fascinating stuff right at the cutting edge. I've really enjoyed talking around how you are taking the latest neurophysiological research into how the brain operates and translating that into how to create new models effectively, and using symbolic representation as a key part of doing that. And there's so many benefits that we've talked about, from the energy. I think that is a really critical way of thinking about just making a much more efficient way of processing information. It makes sense. Brains are efficient, and so it helps there with our needing less energy, but also from a sovereignty perspective as well. I think what you were saying about control was really important as well. So it's been really fascinating to hear what you're working on, and thank you very much for joining us on the podcast today.
Thank you. And sorry, I'm possibly not, let's say, talkative as other people, but I did my best to explain.
It's been great to have you on, Nikolay. Thank you very
Thank
much.
you very much. Thank you.